Have you heard of the nitrogen cycle? Maybe someone in your class talked about it, your teacher talked about it. Let's see if I can clarify what it means and why it is so important for us. So the nitrogen cycle is important because in our body, the code that defines who we are is what we call our DNA. And our DNA, they're long molecules, and in those, we have nitrogen atoms. Now, the big question is how do we get those nitrogen atoms from the environment all the way to our body? And that's why the cycle is important. So the key part here to keep in mind is that nitrogen happens to be in abundance in our atmosphere. So here, the atmosphere. So about 78 to 80% of the atmosphere is made of nitrogen gas. Now, there are other gases. For example, we have oxygen that we need when we breathe. There's some carbon dioxide, and there's a few other gases that are also present, and many in very, very small quantity. But here we need to figure out how we can get the nitrogen from the atmosphere into our DNA, which are part of us as humans, and indeed our cats or animals that you may have. So let's see. What's interesting when we are inhaling and breathing? So when we inhale, we have nitrogen, oxygen, and carbon dioxide going in our lungs. And then our body takes some oxygen, dumps in the carbon dioxide that we don't want, and then we exhale. By exhaling, we get rid of what we don't need, carbon dioxide. But when we breathe, that's 78 to 80% of nitrogen here. When we inhale air, it goes in and then it goes out, and it never gets absorbed by our body. So the question here is that if the nitrogen gas cannot go from the atmosphere into our body, how does it work? And that is what we're going to talk about today, the nitrogen cycle. So here I'm going to talk about 3 words that are summarizing what we have with respect to the cycle. The first one is what we call the nitrogen fixation. So here what we have bacteria. So let's see if I can. So we have bacteria. So there are bacteria that will take the nitrogen like this and will create new substances. For example, NH3 like this, and NH3 being here ammoniac, and NH4, which is ammonium. Now, what's interesting with that is that those bacteria in their metabolism will take nitrogen gas and create these two new molecules. Now, for us, we cannot metabolize nitrogen. However, so bacteria can. And that's interesting because when we think of ammoniac and ammonium, plants can use those as fertilizers. So when we have in the soil bacteria, they will take these into the soil as fertilizers. And that is fertilizer. That's amazing because these bacteria are taking the nitrogen from the atmosphere and creating nutrients for the plants and also the food that we grow as well. And that is kind of fun. Now, interestingly enough, humans don't have much to do with this one. Ammoniac, ammonium, they're molecules, but we don't metabolize them. So we need another process. And the next process also needs the help of bacteria. And those bacteria, what they do, they take these and they create new molecules. And now here they use oxygen in their structure. So we have here NO3 and NO2. So here, this is what we call polyatomic ions. So here we have nitrate, which is 1 atom of nitrogen and 3 atoms of oxygen. So those bacteria, when they metabolize these molecules, and when these molecules are in contact with water, things are going on, and then we have new compounds. Now, what's interesting with the nitrates and nitrites is that they are soluble in water. So they can, if you put it in water, they will dissolve nicely. So here we have these ones here, and here they will go into the ground, but also into the lake because they can be dissolved in water. Dissolves easily in water. And it's quite amazing because now we have new molecules and we need nitrates. We need nitrates as nutrients for our body. But on top of that is that those groups of atoms here, they have a negative charge. And that negative charge will be happy because if you have, for example, NO3 with a negative charge, this will attract minerals as well. For example, iron, magnesium, calcium, potassium. So when you have these minerals here that will attach with the nitrate, these nitrates will be absorbed by the trees as a nutrient, but also the plants as well. And that's quite amazing because the plants use the nitrate as nutrients. And guess what we do with plants? We eat them. So by eating them, we have access to this nitrogen indirectly. So we cannot get it from the atmosphere, but we are getting it through the action of organisms. And that is quite amazing. So here, the bacteria here go even, and they have a synergy with plants, where the bacteria and the plants are working together. So for example, there's some bean plants where when the bacteria goes into the roots, the bacteria are taking fertilizers, metabolizes it, creates these nitrates, and send it straight to the plants. So the plants enjoy that tremendously. Good, good, and good. The next thing now, so here you could see how the cycle is moving. The last part will be what we called denitrification. So here you could see the creation of the nitrates, and here we are dismantling them. So here, either through the environment, the acidity in the environment, some bacteria, some unstable molecules, what happened is that we have the nitrates and the ammoniac and ammonium that will be breaking down and will create either nitrous oxide or could actually go back to the nitrogen gas. And what are those? They're two gases, and then they're going back into the environment. So here we have this nitrogen going back up in the atmosphere. And that's part of how it goes when we have trees that are falling down. We have materials, we have components, nutrients here that are going back into the soil. And then from there, being used as fertilizers, being used as new nutrients. And then what happens is it goes back to the atmosphere. So all of this is what we call the nitrogen cycle. So this happens in on land environment. However, if you think of our small lake here, this also happens in aquatic ecosystems. Because in aquatic ecosystems, we also have bacteria. We also have algae that are plants, and the same thing happens here. What we have to be careful though is that when we have natural fertilizers, land works nicely. So here, this is a topic that I teach in grade 9, but also in grade 10 when we talk, in grade 11, when we talk about agriculture. So if you have a farm here and you're growing plants, and what you do is that you are collecting the plants because you're harvesting it to create food for humans. You are taking nutrients from the soil for the plants, and then the plants are taken away. So slowly, if you're not careful, the quality of the soil here, the nutrients in the soil will decrease. So if you are, for example, if you have an organic farm, you're doing what you need, you create a rotation of culture of plants that you grow so that you can keep your soil healthy. And if you don't, what humans do sometimes is they use processes, create fertilizers, and they put here industrial fertilizers in order to keep the soil ready for more growth. The big issue though is that if you have over exploitation of land, there's an increase in the quality of the soil. So you have to be careful of that. And the other issue we have with humans when we try to play with our environment is that if you add fertilizers to the ground to grow plants faster, these these fertilizers sometimes they end up in rivers and lakes. So what happens is here is that you have algae that receive nutrients through the fertilizers put there by humans, and then you end up with environments where there's more and more nitrogen, and we have an issue that we call eutrophisation. And if you want me to do a video on eutrophisation, I'll be more happy to do that for you. Or if you want me to clarify that later, I'll do that as well. So you end up with a lake where there's an increased number of plants in the lake. And what happens is that you have more plants, less sun goes to the bottom. Another issue is that more plants are decomposing, the oxygen level decreases. So if you have little fish at the bottom here, let's see, a little fish here that is quite happy, if there's not too many algae, you end up with ecosystems where you have a decrease in biodiversity in those lakes, and that is an issue for that. So the nitrogen cycle is amazing. It's a cycle that happens naturally. Humans with their nice brain are working with that to make sure that all humans have food to eat. But we have to be careful. So if we make sure that we have less food thrown away, we don't buy more food than we need, and then we are mindful of how much waste we create, we can minimize how much fertilizers we use, we can decrease how much nutrients are taken out from the land, and we can have, as good as possible, a nutrient cycle with the nitrogen that has a long-term viability and sustainability. If you have any questions or clarification questions with the nitrogen cycle, don't hesitate to put them in the comments below. I always look at them to answer, first of all, your questions and get some ideas for more videos for this channel. So if you enjoyed this video, don't forget to subscribe to our channel. And I'm going to put here a video about the carbon cycle where you'll learn so much more as well. Let's see what else we're going to learn together.